My topic is about pattern mining and pattern recognition. What is pattern mining means? The identification of relevant patterns that can aid in improving the business model with the discovery of frequent items based on the association rules. For mining altogether is nothing but frequently used data has been identified is known as pattern mining. We are going to see what are the concepts of. There are four concepts. First one is frequency pattern. It could be subsequent or the subset that are observed frequently with respect to user specified threshold. Pattern frequency pattern mining means it involves identifying the recurrent patterns in the data. Recurrence pattern means repeatedly used data has been identified by frequency pattern mining. Frequency items in mining means it involves identification of association or the correlation between the data items from the used data. Used data is nothing but database. It will identifies the what is whether it is a strong relation or a weak relation between the data items from the used data. Association rule mining means association rule mining will detect the commonly usage of the item. Means it will detect what are the commonly used data in a from the used data set. Means the purchasing of a product X when Y has also been purchased. This will be understand with an example. The example will comes under market basket analysis. Market basket analysis will tell me it is one of the most popular methodology to increase the sales of a product in stores by finding the association between them. The idea is to bring the set of products together that has some kind of interdependence in terms of their use. I will give an example. For example, when you go to a supermarket, what you will see certain items has been arranged in certain order. That is, chocolates are arranged in one session, vegetables are arranged in another session, etc. and so on. So a particular pattern has been followed based on the previous transaction. Whenever any person buy bread, it is obvious that he will buy some jam, peanut butter, or some of the other things that is used with that bread. That is, purchasing of a bread leads to be the purchase of many other items along with it. So the shopkeeper planned it in such a way that here they also keep the shelves of bread after the bread jam, because it is obvious that if a person buy a bread, he will buy he will also gone for jam and butter. How does shopkeeper comes to know? They also known on the basis of previous transaction. Suppose there were 10 customers who visited the supermarket. The shopkeeper realized that all those customers from 9 out of 10 they buy bread and butter. So the shopkeeper keep those things certain things together to increase their sales. One is let us represent the association and procedure with an example. Suppose there is a set of items I is equal to I1, I2, I3 up to so on IM in a database. Database DB consists of transaction T1, T2, T3 up to so on Tn. Each transaction T contain a set of items that from capital I. Suppose M is a set of items in a transaction Tx. Association rule express an implication M implies N in a database transaction where M subset of I and N subset of I and M intersection N is equal to none. By establishing this relation, we actually put forth the relations and the association between the items that can improve highly beneficial for the business decision policies. Pattern mining is mostly useful for the business people only. What is a priori algorithm? A priori algorithm is it is an application under pattern mining. A priori algorithm is nothing but finding the frequently used items. It has two steps. First is finding the frequently used items, and second one is whether it is there is the whether strong relationship or weak relation between the data item sets. Here we can see the one table. The table consists of um, transaction and the data items. Transactions means there are six transactions. Transaction is nothing but there are six persons or six transactions. The transaction T1 will purchase three items IBL. What is I supposed to be? iPhone, B is Bluetooth, L is laptop. Where T3 is L and U. L is laptop, U is USB. The transaction T3 will purchase these two items. This table will useful for while we are going to an example of a priori algorithm. First, look into the terminologies. What are the terminologies in a priori algorithm? 5 terminologies. The first one is item set. It is a collection of one or more items. For example, I and B. I and B is a one more than one items. The two items is combinedly known as item set. Here we can see in this table there are 6 item sets. This is one item, this is one item set, 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 this is one item set. Support count is, it is a frequency of occurrence of an item set. For example, support count is equal to IBL is equal to 2. How we got this value as 2? IBL, how many times it has been occur in data items? IBL in transaction T1 it has been occur, in transaction T5 it has been occur, means first one time, two times is equal to 2 times. By this table only we have got the support count. What is support? Support is different from support count. What is support? Support is equal to support count of X union Y divided by N. In capital N is number of transactions. How many number of transactions? 6 transactions. So 6. Support count S is equal to, we are going to find the support count of X, I and B. How many times I and B has been occurred? Here 1 time, 2 times, 3 times, 3 by 6. In this way we are going to find the support value. What is confidence? It is a we will see with an example and a formula. Support count C is equal, confidence C is equal to support count of X union Y divided by occurrence of X. For example, we are going to take an example, L comma U. How many times it has been occurred? L comma U in transaction T5, in transaction T3, 2 times. So support count C is equal to, confidence C is equal to 2 divided by, what is M? Occurrence of X. Occurrence of X means X, how many times it has been. In this X means L. How many times it has been occurred in the L? 1 time, 2 time, 3 times. So we are going to write 3 values like this. Last terminology is frequency item set. The support count is greater than the minimum threshold value. Before going to an example, we have to set the minimum threshold value. In this example, we are going to set the minimum threshold value as 2. We need to remember the minimum threshold value as 2. It is more useful. Frequency item set. Support count means what we are going to find the support count value. You will understand this with an example. A priori property. All the non-empty item set of a frequency item set must also be frequent. Means non-empty means it should have some item sets. It should be frequent item set and must also be frequent. What are the operations? There are 2 operations, join and preend. Join means we are going to join more than 2 items. Preend means we are going to remove the items which does not, we support count should be greater than or equal to threshold. If support count is less than or equal to minimum threshold value, then we preend the item set. This is an example. From here onwards, a priori algorithm example has been started. What is C1 is candidate item set, F1 is frequency item set. This is, we have 5 different items, so item set is equal to 5 different items. We have wrote. What is count of occurrence means how many times high has been occurred? 4 times. How we got the value as 4? By using this table. I in 1, 2, 3, 4. 4 times it has been occurred. How many times M has been occurred? 2 times. Where in transaction T4, in transaction T6 M has been occurred 2. How is the frequency items that are going to find out? It should, the support count means count of occurrence is equal to support count. Support count value should be greater than or equal to minimum threshold. What is the minimum threshold value? We have taken 2, means count of occurrence value should be greater than or equal to 2, means these are all values are greater than or equal to 2. So F1 is nothing but frequency item set. So we write these values in this table. So we write all these values in table. But we have taken only single item. In the next table we are going to take two item sets, that is considered as C2. Let's look into the item set. See, we have taken two items. Then we are going to find for these values we are going to find support count. Support count, how we got IB how many times occurred? One time, two times, three times. So we are going to write as three times. How many times BU has been occurred? One time, here two times in transaction T2, in transaction T5 two times it has been occurred. So BU value is 2. Again we are going to see support count should be greater than or equal to 2. In this we have this is greater than or equal to IB as greater than or equal to 2. So we consider this value, this support count is greater than or equal to 2. We are not going to consider this value. We are going to consider, not going to consider, because the 1 is less than or equal to 2. This value should be greater than or equal to 2. So those values only we are going to consider and keep those values in F2. What is F2? Frequency item set table. See, we keep these IB, IL, IM, BL, BU, LU values only here. See, this is F2. Not only two items, we are going to keep three items. See, data set items has three items. C3 is nothing but frequency item set. Three item set, candidate item sets. Three IBL, because IB, IL, BL are there in F2 table. IB, IM, BL are not there in F2 table. So we are not going to take this value. We are going to take only this value and this value. See, IBL, BLU. For this we are going to find the support count value. IBL, how many times it has been occurred? IBL in transaction T5, in transaction T1, T1 IBL, T5 IBL. So two times. So we wrote the support count value as 2. Next, BLU, how many times it has been occurred? One time. Where? In transaction BLU how many times? T5 in transaction T5 BLU one time. So support count value should be greater than or equal to 2. Here support count value is greater than or equal to 2. Here it is not equal to 2 or it is not greater than, it is less than 2. So we are going to consider this one value only. We are not going to consider this value. So the table is here. This is the frequency item set value. We are consider only first one value. Um, After finding the frequently used item, we are going to find out the association, whether it is a strong association or a weak association, by using this formula. Support count of Fi divided by support count of X greater than or equal to confidence threshold. The Fi is IBL. We can, Fi is considered as IBL. What we have got from F3 final table, what we have IBL value, that can have values. This value can be represented as IB, BL, IL, IBL. See, I intersection B, leftover is L, so tends to L. B intersection L tends to 1, B intersection L tends to B. So we wrote these values. I tends to, leftover is B and L, so B intersection L. B leftover is I and L, I intersection L. The numerator is written as 2 because we have taken threshold value as 2. See, numerator. Denominator is dependent on these values. This value, how many times it has been occurred in the table, we are going to take. IB has occurred in 3 times, BL 2 times, IL 2 times, I value 4 times, B value 4 times, L value 3 times. So by calculating this we get 67%. By calculating 100%, 2 divided by 50%, 2 divided by 67%. Why we have written this symbol means it is 100% because strong relationship it shows. The association rule generate only these two values are strong association, leftover are weak association. Only these two are strong association. This is all about pattern mining.